modernized toolchains to create JSPatcher objects and WebAudioModules from Faust code. And this is a joint research with Graham's research team. So Stéphane, Letz, Yann, Orlarey, Dominique, Fober, and Romain, Michon, and my PhD supervisors, Laurent, Pottier, Michel, Buffa, and Yann. So the paper is mostly about Faust, which is a domain-specific language that is quite present in the web audio community in recent years. It was born in 2002 at Graham and has been used in various artistic education and research projects. So over these 20 years, a lot of compilation targets have been developed for the language. So today, DSP written in Faust is runnable on native and web platforms, mobile phones, embedded devices, and so on. Our growing community is keeping developing robust DSP libraries, so we aim to provide useful tools for them to easily test and deploy their audio programs. In this paper, we present a new JavaScript library called FaustWasm with two important use cases in WebAudioModules and JSPatcher. So a brief history about Faust and WebAudio. In 2015, we had a first version of our Faust compiler running on the web based on ASM.js specification. It means that for the first time, we can compile a DSP written in Faust language and run it directly in a browser. In 2017, the new WebAssembly format makes the compiler much more efficient, and the compiled DSP can be wrapped as script processor or even AudioWorklet. So it is compatible with other WebAudio nodes. Web-based code editor was developed using the compiler, allowing users to write and test their DSPs on web, called FaustWebEditor. In 2019, when we developed the Faust IDE, as well as the FaustWebAudioModule. The module was the core of the Faust IDE for compiling Faust code to WebAudio nodes. And it has been used in other projects as well, including JSPatcher. After that, we were continuing integrating Faust into more WebAudio projects. We found some limitations from Faust to WebAudio in some use cases, and we decided to rework on C++ side of Faust compiler in order to develop a new compiler module called FaustWasm. So there are several reasons for us to do this upgrade. First, in the Faust repo, we have tons of HTML and JavaScript files that are kind of outdated. Most of them contain the duplicated code because they were all used to create different versions and formats of web-based DSPs. We can now clean them up and create a unified module to wrap the generated WASM DSP. Second, to run a Faust DSP on the web, we don't necessarily need to also compile the DSP on the web. Instead of doing this kind of dynamic compilation, one can pre-compile the WASM DSP elsewhere, then import these static WASM files and wrap them as WebAudio nodes. This is something we could not do with FaustWebAudio. Then, using the latest version of Emscripten with some minor hacks, the generated WASM Faust compiler can be loaded in either Node.js or AudioWorklet thread. It means that we can now prepare the WASM DSP using Node.js offline to save some performance in runtime. Here is an example of using Node.js and one line of command to compile a static version of Faust DSP. On the Node.js side, FaustWasm will load the WASM Faust compiler to compile the DSP source codes to two files. one wasm file that contains the DSP program and one JSON file that provides the metadata, such as the DSP name, author, and UI configuration. Then, along with these two files, the script copies a set of glue codes for running the DSP in a standalone web page. We put an HTML file with bundled versions of FaustWasm and FaustUI modules, so user can have a nice looking interface for DSP parameters and audio I/O selection. Now we can talk about why this is useful for WebAudioModules or WAMs. So last year we formed a working group for WAM version 2, including Michel, Buffa, and me, Stéphane, Letz, Owen Campbell, Yari Primola, and Stephen Yi and Tom Burns, and so on. We wanted to make WAM a standard for web-based audio plugin that can be fetched and loaded from a URL as ES module. Each WAM is an audio worklet with customized API that can schedule sample accurate parameter automations or media events from both main and audio thread. In the previous WebAudio conference, we demonstrated a GUI builder inside the Faust IDE to quickly generate audio plugins from Faust code. This system was also adapted to the new WAM standard. In fact, we can make the process even more simple by just using the default UI of the Faust DSP. So we created the Faust to WAM module for this purpose. With the existing Faust DSPs, we will be able to generate tons of audio plugins using several lines of code. Since the WAM API is different from the AudioWorklet Node API, especially for event handling and parameter automation, it needs to be implemented separately. From the WAM SDK, we imported the parameter manager and the composite node as an API proxy to wrap the Faust AudioWorklet node. The param manager will be able to automate audio params inside the Faust AudioWorklet node and to send MIDI messages from the WAM API. In the WAM's initialization phase, FaustWasm will generate nodes from precompiled static wasm DSP, or can also be directly from Faust source code. Here is an example of the generated folder for our Faust WAM. So it is actually a polyphonic instrument, a virtual guitar, with a general effect applied to every running voice. So in the folder, we can see two separate WASM DSPs, DSP module.wasm and effect module.wasm. This is a screenshot of JSPatcher where I loaded 3 different WAMs from URLs generated by Faust to WAM, and the guitar instrument, ping pong delay, and reverb. Okay, now I will spend some time on JSPatcher. It is a web-based visual programming language, VPL, written in TypeScript in style of Max or Pure Data, allowing users to create interactive online applications by building a graph. We will keep adding audio features into the system. In 2020, we integrated all the native WebAudio nodes as connectable objects. And last year, we made a Faust-based graph-to-code interpreter. It generates in runtime a piece of Faust code that is corresponding to a given patcher and compiles it into AudioWorklet nodes. However, we wanted to add more precompiled basic DSP objects to the system to extend its possibility for real-time signal processing. actually, we already have a Faust library called maxmsp.lib, which is also a community contribution. Our work reused some functions from this library and prepared for each DSP object a dedicated Faust source code file. The resulting objects are in max or PD style, which means some audio inputs can be initialized using the argument, and they can be changed using non-audio data. To achieve that, we are using the declare keyword from the Faust language to provide the object's general description and the description for each input, default input values, and argument mapping. These are shown in the JSPatcher interface. Okay, maybe you already saw the installation in the entrance of the conference. So part of the program is made by these objects. So I'm going to show one patcher here of this installation, in which you can select and mix some sounds. These knobs at the bottom are actually Q and frequency parameters of peak notch filter objects. I opened the patcher so you can see how these Faust-based DSP objects interact with WebAudio ones. I can play some sound, hopefully. I think due to the screen sharing, my CPU is lagging for the audio here, but maybe you can, okay. Conclusions. So we developed the FaustWasm module for generating statically and dynamically Faust DSP code in different JavaScript environments like Node.js, Web, Audio Thread. And on the top of this module, we made FaustWasm, a tool for creating WAMs automatically from Faust code, and also JSPatcher's DSP package that includes tons of precompiled audio objects. And in future, we will use FaustWasm to replace FaustWebAudio in Faust IDE, Playground, and Web Editor. We are trying to make the generated DSPs that supports simple, accurate event handling, parameter automation, and MIDI messages. Then hopefully more and more ready to use AudioWorklet nodes. These modules are all available and open source on GitHub. So feel free to use them or leave comments. We will be happy to discuss with the community. And that's it. Thank you very much. And feel free to ask if you have any questions.
Thank you very much, Shihong. Are there some questions?
I'm sorry, I was just stretching myself.
Thank you very much, Shihong. I think this is great. Having something like a patcher in the web, and very thank you for sharing it to us. And I just wonder, besides all you have done about the audio schema and API coming from Faust to wasm, how do you deal with messages around your objects you compile for into you and load into your patcher? I mean, are all the controllers And how do the controller are implemented in your objects so that in your patcher we can share some nodes, control, etc.?
Yeah, very good question. And actually, it will be too long if I present all these features in this session. But if you are interested, I presented all the messages or data flow aspects of JSPatcher in last sound and music computing conference in Saint-Etienne. But in brief, these all the web API actually, or all the JavaScript interface in the web are all imported into JSPatcher. So you can basically everything you can do with JavaScript, you can do with the patcher interface using just boxes and lines and connect them. And we also have some basic UI component for you to generate events using buttons and toggles and things like that. So yeah, don't need to worry about the messages.
Shihong, maybe you could show the Faust IDE and the default generated interface for an effect or an instrument, and so that people can understand that what they see in the IDE can be just generated using a line command and reused in any web application.
Yeah.
Share your screen.
Yeah, I will share my screen. So yeah, here in the IDE, you can see a simple algorithm for distortion effect. And this part of the code will generate, if I turn sound off, this interface with one parameter. And I will open some code.
So actually, maybe you could show a more complex UI, like the free verb or anything.
Yeah, sure. Yeah, free verb here. Okay. This is the interface of free verb and Faust IDE. And you can have the same thing in JSPatcher. Let me just open.
So from the Faust IDE, you can generate GUIs automatically, test the plugin using a live input or a MIDI keyboard or sound samples, and then you can create some code that you can reuse in any web audio application. And Shihong, just by using the generated URL, can also integrate them into his patcher. So you don't have to take some time for building your own GUI if you want to rely on this default GUI.
So here is the free verb loaded using a single URL. And this is the container of the plugin interface. I will try to activate the sound. Okay, I think my computer is lagging for some audio.
I think
yeah.
Il a pas partagé le son. I think you didn't share the sound. Okay.
Okay, thank you, Shihong. I'm not sure we have time for another question. We are 10 minutes late. Thank you very much.
Thank you.